Okay, so here's an example. A city's population can be modeled by the equation P equals 1.4 times 1.0415 to the power of T, where P represents the population in millions, T years after 1985. In which year did the population first exceed 3 million? These are the questions where you're going to have to go ham and then go back and read it. Okay? And then you have to understand that your letters, they can be any letters, just understand what they represent. So, this is the equation. What kind of equation is this? What kind of equation is this? Like, is it quadratic? Is it linear? Is it exponential? Is it whatever? I don't know. What is it?
Quadratic.
Wow. What is it?
Exponential.
And how do you know it's exponential? Because that's
it has exponential in it.
the exponent is a letter, right? So because your exponent is a letter, now, does it look like something like this? With different letters and numbers, obviously. Does it look like this? Okay. What's Y in this case? What letter is Y? P. What's A?
1.4.
What's B?
1.0.
And what's X?
T.
So you see, it looks different, but it's the same. Right? Now, P represents what in this scenario?
Population.
P is the population in millions. So you have to be careful that whatever your answer is, if your answer is 1, that means it's 1 million. If your answer is 10, that means it's 10 million. Okay? And T represents what? The years after 1985. So that's very important because T1 represents what year? 1986. T10 represents 1995, right? So you have to be careful that T, the value of T, is whatever number after 1985. So 1985 is your year 0. Right? And then everything after that is going to go 1, that means it's 1986. 2, 1987. Well, and so on and so forth. Right? In which year did the population first exceed 3 million? So what are they giving me in this question?
They're giving you the population.
They gave me what letter? That means
Uh,
if they gave me the population, what letter is it? P or T?
T.
Population.
P.
P. Right? So in which year? It's asking me for T, so I don't know what T is. In which year will the population exceed 3 million? Okay? So they gave me P. Now, what's my beginning population, we said? What's the beginning population? How do I know what the beginning population is?
It's in your.
What's my initial population? Which letter represents initial in this equation? A. What's A equal to in the equation?
1.4.
So I have 1.4 million, right? That's my beginning population. So I'm starting with 1.4 million, and that is in year 1985, right? In year 1985, I had 1.4 million. What's the ending population that question is asking me for?
The end?
Yeah,
Hang on. In which year did the population first exceed 3 million? So 3 million?
3 million. That's my ending population. So it's asking you what's your population is growing at a rate of so remember the formula where I said y equals a1 plus I to the power of x. Remember that formula that I've used in the next slide. the rate is the I value. Okay, so 1 plus I gives you this. Gives you 1.0415. Okay, so 1 plus I gives you the 1.0415. So how can I find I? How can I find I?
You take the 1 over to the other side, you subtract it.
That's right. So I is equal to 1.0415 minus 1, which is 0.0415. And as a percentage, because I has to be a percentage, what do I do to find something in percent?
You times it by 100.
Times it by 100, right? So if I multiply this by 100, that gives me 4.15%, right? So that means my rate is 4.15. Now, in this case, I don't really have to do this. It's just the question is asking me to, like, as a step, but you don't have to find it. Now, let's write the equation. So I know that I need to solve for t when p is 3 million, right? Yes?
So you go 3.3.
Just 3
Bracket.
equals, because 3 represents my p.
Oh, right, so equals, yeah.
3 equals 1.4,
Yeah.
1.0415 to the power of
T.
t.
Right. And you want to find T.
Can I have your attention? So I'm looking for an exponent t. How would you isolate for that?
For T?
Yeah.
Yeah, so you would divide out the entire bracket and the 1.4.
So,
You divide it, you take it to the other side and you see that.
so you see that this and this, I can't mix them together because this is to the power of t. This is not to the power of t. So I can't do much about this. Okay? I have 1.4 times this bracket. What do I have to do? You divide 3 by 1.4. Yeah. So you're going to have to move that 1.4 over. Okay? Because this is a multiplication, when I move it over, it's going to become a division. So remember, the most important thing is that the 1.4 and then 1.0415, you can't mix them up. They're separate. So if I do 3 divided by 1.4, what do you get?
2.14.
3 divided by 1.4 is 2.14. Is that what you said?
Yeah, 2.14.
Now,
Now,
what do you think I need to do to solve for t? How do I learn? Did I learn anything yet to solve for t? It's a power. Remember, it's a power. It's not multiplication. It's not division. It's not addition. It's not subtraction. It's a power of t.
oh, square root it?
I can't because it's not a square. I don't know what t is. I don't know what root I'm going to take.
Is it long?
Yes, but they haven't learned about it, and that's the next page. So, okay, I'll teach you that in a bit. So in this case, I'm going to have to do trial and error. Okay, trial and error means plug in values for t and do 1.0415 to the power of that, 1.0415 to the power of that, until you reach an answer that's close to 2.14. Okay, so give me a number for t. Give me any. Let's start with a value.
Okay,
2. So if I do 2, let's see, 1.0415 to the power of 2. What do you get?
1.084.
So it did not change much, did it?
Okay, no.
cannot, T2 is very, very, very small. Remember, I'm trying to get to 2.14.
Yep.
Okay.
So let's try 10.
10. What is the answer?
1.5.
So it's getting bigger, but it's still way away from 2.14. 1.5 what?
0, 1, 7.
Okay.
Okay, so double it. So 20.
20? Okay. Again, it's trial and error. You could want to try different numbers, but we're just 2.
2.25.
Okay. What's happening now?
Now we're over.
Now we're over.
So let's make it 15. Did I say 20? Let's make it 15.
What do you guys want to try? 18? 18? Because it's pretty close, right? So I can try.
Yeah, 15 is too little.
Okay, so let's try 18.
Yeah.
It's more than 18.
No, it's 2.07. Maybe let's try 19.
Yeah. Because we know it's not 20 and it's not more than 20.
Yeah,
We know it's close to
18
it.
is 2.07.
So let's try 19.
Yeah, it's gotta be.
2.16.
And then what is my answer? Actually, it has to be 2.14. So because it has to be more than 3 million, right? Because I'm looking for more than 3 million. So technically 3 million, that's going to give me 2.14. So T equals 19 is your right answer. Okay? So it's between the 18th and the 19th here. Okay? Because what I got here is an answer that's pretty close to this.
Can you do 0.5?
Sorry?
Can you do like 18?
You can, but remember, because I'm looking for when would it be more than 3 million, I can say 19.
Oh, okay. So then that's
So if year 1 is 19 or year 0 is 1985, after 19 years, what would be that year? So remember that 1985 is year 0. 19 years after that, what do you do?
So it would be 2004.
So 2004 is when the population reached 3 million.
Right.
Okay? So the population
So do you count 85 or do you start from 86?
you count 85. You just 1985 plus 19. So trial and error could be a little bit long. And not accurate.
Did you see my struggle?
All right.
I got more.
We talked about this. I don't need to go over it. They use different letters. We said it's okay, right? A0 is your initial amount. It's called A naught. That's what they usually use. A0, that's what means that it's short, or A naught, it's the initial. Right? And a D is your doubling time. And H is your half live time. Now, for the grade 12 college, not the tech, log is not part of the curriculum, but log is an easy way to solve questions like this instead of actually doing trial and error every single time. You want to do trial and error, go ahead, but there is a way to do it. I'm going to show it to you. You don't have to use it, but you can use it if you want. So it will only be demonstrated and not explained why this happened. Okay? So anytime I need to use I need to solve for an exponent, so to solve for an exponent, the best way to do this is whenever you have an equation, you take the log of both sides. Okay? So you see on your calculator there is a log button. Can you check it? It should look like this, log with a square next to it. Now if you see another one which has a square here, we're not going to use that one. We're just going to use that one.
There's no square. A, B, and then just log.
Just use that log.
Does this, is it this one or that one?
Yeah. So it won't have a square, it just says log.
Does it have a bracket?
It doesn't have, it just says log. It just says log. You see that?
Mine has like a bracket.
Yeah, when you press it, it will give you a log. Yep. That's good. Okay, so if I do log of both sides, the rule says if I'm looking for an exponent, I'm solving for the exponent. Okay? The rule says if I take the log of both sides, so log of 5 equal to log of 1.06 to the power of x.
Is that put equals in the calculator? I don't think
Yes, but just wait for it. Don't put it in yet. Okay? So, because I'm looking for the exponent, I'm going to have to do the log of both sides. Once I do the log of both sides, that forces the exponent to come down as a multiplication. So then I don't have an exponent anymore. Eyes on me for a second. So that log forces the exponent to come down and become a multiplication. So that makes it log 5 equals to x log of 1.06. Okay? Now, what happens is I have a multiplication between the x and the log 1.06. So to isolate for that x, because this is a multiplication, what do? What's the opposite of multiplication? So I'm going to bring the log 1.06 as a division. Right? So that means bring this over as a division, and that becomes log 5 over log 1.06. Right? So, which means you're going to have the log of the y over the log of the base. Okay? Which is, you on the calculator, do log of 5. Like do your, you guys have the good calculators, so you have this button. Okay? Use this button and then do log 5 and then down log 1.06. What do you get? So instead of me doing trial and error and sit down and try to plug in values for x to get the answer, right? I can say that x is 27.6. Now, you can try, okay? You can actually put 27.6 here as a power and see what you get. So do 1.06 to the power of 27.6. And you should get a number that's close to 5 or equal to 5. Yeah, 4.99, right?
But we
Which is
just
fine.
rounded up to
No, leave it as 27.6.
But if, for example, if it was the other question.
Yeah, if you're looking for years, you're gonna say about 28 years.
Oh,
Yeah, but I mean, if the question is saying how many years, right, and then you're looking for years, right, you don't say 27.6 years, you say about 28 years. Right?
Put 26, you put 28.
What is it?
Then you put 26 there, you said instead of putting 26, you put 28.
Instead of putting 27.6, you can say it's about 28 years. If we're looking at years, right, if we're looking at a word problem. So, what do I do for this one? I'm looking for the exponent, and my exponent is 2x. What do I do for this one? Since I'm looking for an exponent, what do I do?
still the same thing.
Log of both
Log
sides.
25 equals, uh, 2x.
I'll just write this here. Okay, so I took the log of both sides. Then what happens when I take the log?
So then you do log 25 equals 2x log bracket 0.97.
Yeah, so your exponent is gonna come down here. The whole exponent is gonna come down as a multiplication. So that's gonna be log of 25 equals to 2x log of 0.97. Then
Then what we do is you take the log 0.97 and you move it over, so now it's divided by,
so I have log 25
yeah,
divided by
log 0.97 equals 2x.
2x, yeah.
Now we get,
Find the answer for this, please. What do you get? Mm-hmm. Mm-hmm.
negative 105.6.
So negative,
105.6.
okay? The reason why you got a negative, eyes on me for a second. Anytime you do log of a number that's less than 1, between 0 and 1, you're going to get a negative. So this is a positive over a negative, it's going to be a negative. That's fine. We're looking for x value. So equals to 2x. How do I solve for x, guys?
Divide by 2. and
Divide by 2. Divide by 2, right? Because you want to get rid of that 2, so you're going to have to divide by 2.
Divide by 2, so then you get negative 52.8 equal x. So now let's check that.
You can check that. Yeah, you can put that in here and see if you get close to 25.
How do you exponent 2?
So do exponent 2 times yeah,
Oh,
negative 52.2.
so.
No, because it's multiplied by 2.
Oh, and then it turns positive.
Yeah, yeah.
So
Because
it's
you,
24.94.
yeah, good.
You have to do.
Yes, because it's, if you look in the equation, 0.97 to the power of 2 times x. So 2 times whatever you got here. You get that? You got 25? Fine.
Negative 49.
Put the bracket. Put bracket around the 2 times negative 52.8. You need to get yourself a nicer calculator. Trust me, it will make a difference in your college. This is one of the calculators that when I did the dual credit for MCT 4C when I was a Durham College teacher, and I did the dual credit MCT 4C at the high schools. This was the calculator that the college provided the students.
It's so. I'm getting 0.9.
Okay, try it again. So
Oh, I
you're
did something wrong. No, that was my fault.
Okay.
Oh, that was human error. I should.
got it?
Yeah.
Okay. Try this one. I want you to try this one, and then after we will do the next question, which is one more question.